Polymorphism means many forms. In C++, it is known as polymorphism, but is also referred to as late binding or virtual functions. It's definitely an ontological word. In the last presentation, we discussed the dangers of dynamic memory, such as shallow copies and memory leaks. We also looked at how the big three functions could help overcome these problems. If we have dynamic member variables in a class, they are generally private, so it's up to the class to delete them using the destructor. Copy constructors and overloaded assignment help us with the shallow copy problem. Back in Module 1, we also looked at inheritance, where we could have a specialized version of a class known as a subclass. So, what does this picture mean? Well, here we can see that a dog is a pet. It has everything a pet has plus more. A cat is also a pet. Likewise, it has everything that a pet has plus more. So, can I make a dog a pet? Well, logically this should be okay, but the code that you see on this slide doesn't work. Okay, how about this assignment statement? Well, this one doesn't work either, but a dog is a pet and we're working in C++, so we should be able to do this somehow. Well, we can assign a derived class to a base class, but we end up with a phenomenon known as the slicing problem. Object slicing happens when a derived class object is assigned to a base class object. The additional attributes of the derived class that make it special get sliced off in order to conform to the base class object. This is C++ though, so you can be sure there's a workaround to the slicing problem. We can use pointers, and the code snippet that you see here actually works. It is only allowable since Fido is a dog, which is a pet. We can also use dynamic memory to get around the problem. Okay, but why would I make a dog a pet and not just keep it as a dog? Well, we might want to write code that could ask the user what type of pet they have and have the pet greet them. So if I have three definitions, I should get the one corresponding to the type of pet that I actually own. Since my pet is a pointer, we should use the arrow to simultaneously reference and access the member function. It gives the generic, "Hi, I'm a generic pet" response. But my pet points to a dog object, so what's going on here? Well, we've redefined the function, but we haven't overridden it. C++ knows my pet is a pet pointer, so it calls the pet greet function. But we really want that dog greeting. Well, C++ has a workaround called virtual functions. This term is a bit of a misnomer. Virtual functions are always actually defined. The key is that virtual functions can be overridden. In other words, C++ will always use the function in the deepest subclass. In contrast, redefinition, C++ always uses the level of the pointer. To override, add the keyword virtual before the function name. Then myPetGreet would call the greeting for either cat or dog depending on the type of pet we have. Polymorphism can also work inside member functions. As an example, imagine having a sales superclass and a discount sales subclass. Each one has a bill function. We make this bill function virtual so that we can override it. Now imagine that we also have a member function savings and an operator less than that each use bill. The way in which they evaluate is dependent upon the implementation of the bill. The function bill is virtual in class sale, and the function savings and then the operator less than. They're all defined only in the base class, but we can use the version of bill found in the subclass. When discount sale object calls its savings function, defined only in the subclass, function savings calls the function bill. Because bill is a virtual function in class sales, C++ uses the version of bill defined in the object that called savings. Another example is, say I want to make a video game. I have a superclass called enemy, but there are many types of enemies such as random enemy, heat-seeking enemy, and an avoidance enemy. When making this game, we probably want an array of enemies, and you may have thought the arrays must be all of the same type. Not with inheritance. We can actually do this with an array of pointers. Now, let's say enemy has a member function called move, which is declared virtual. Each type of memory can override it with their own specific behavior. For example, one can move randomly while another moves towards the player. If we use a loop to go through the array and call move for each item, that one line does very different things for different enemies, and we've actually ended up creating a more challenging game. Yes, it is. Polymorphism is awesome and cool, but we can only do it on virtual functions. So why isn't every member function virtual? Well, in most other object-oriented programming languages, Java, C#, Python, every function is essentially virtual. So why is C++ different? Remember, C++ is built for speed, and virtual functions slow things down at runtime. The compiler doesn't know what function will be called, so at runtime we need extra instructions to look up which function to call. This is sometimes called late binding because of this. Overuse of virtual functions can lead to other problems if we're not disciplined. In particular, if you use virtual functions as placeholders and don't define every virtual member function, you may get a host of strange errors. This makes incremental development difficult. If you're going to use them as placeholders, don't just define them as blank functions. Add an error message and exit so that it's never called. Otherwise, it might introduce weird bugs. Finally, try to make all destructors virtual. All subclasses then have virtual destructors. If the superclass destructor is not virtual, only the superclass destructor is invoked. This leaves subclass members not part of the superclass still in memory, and you can get a possible memory leak. In general, be careful out there. Thanks as always for watching, and make sure to check Lima for associated labs and assignments.